Hello friends, this is another lecture of Laplace transformation. In this particular lecture, we will study Laplace transformation of a function divisible by small t, that is of the form 1 upon t into ft. If Laplace of ft is equals to fs, then Laplace of 1 upon t into ft equals to integral s to infinite fs ds. So, for better understanding, we will take some example based on this particular phenomena. That is, the first example is find the Laplace transformation of e raised to power at minus cos bt upon t. So, to solve this particular example, first we have to find what is ft. So, here the function is in the form 1 upon t into this particular ft. So, here ft is e raised to power at minus cos bt. Now, Laplace of this ft is, what is Laplace of this ft? Laplace of e raised to power at minus Laplace of cos bt. So, what is the Laplace of e raised to power at? You better know what is the formula of e raised to power at. That is, Laplace of e raised to power at is always equals to 1 upon s minus a, and Laplace of cos at is always equals to s upon s square plus a square. So, this will convert into 1 upon s minus a, and this will convert into 1 upon s square plus b square. So, this is the Laplace of ft. Now, from this particular phenomena, Laplace of 1 upon t into e raised to power at minus cos bt, which is equals to integral s to infinite 1 upon s minus a ds minus integral s to infinite s upon s square plus b square ds. So, this is equals to log s minus a directly limit s to infinite minus, in this particular case, if we let it something, then the differentiation of this particular term will be 2s ds equals to that particular thing. That is, if we let it s square plus b square is equals to, suppose n, then 2s ds equals to dn. That is, s dn equals to 1 upon 2 dn. So, this will convert into 1 upon 2 integral dn upon n. That is, log s minus a limit s to infinite minus 1 upon 2 log n. That is, and what is n? S square plus b square under the limit s to infinite. Now we have to replace limit in this particular term. So, what we get? Or we can write it as, if there we multiply by 2 and divide by 2, then it will convert into 1 upon 2 log s minus a square minus log s square plus b square under the limit s to infinite. Or we can write it as 1 upon 2 log s minus a square upon s square plus b square under the limit s to infinite. Now, we cannot put infinite directly. So, for this, we can take this s square as a common, that is 1 minus a upon s square, 1 minus a upon s whole square, and from there 1 plus b square upon s square under the limit s to infinite. Now, this is cancelled. So, put the limit log, when we put s equals to infinite, this will convert into 0. So, log 1 upon 1 minus log, this function remains as it is when we put s. That is, we can write it as s minus a square upon s square plus b square. And what is the value of log 1? Log 1 is always 0. So, minus 1 upon 2 log s minus a whole square upon s square plus b square is the right answer for this particular problem. Now, this is second example. Find Laplace transformation of 1 minus cos t upon t square. So, for this, we first let ft. What is ft? 1 minus cos t. So, Laplace of this ft is equals to Laplace of 1 minus Laplace of cos t. So the Laplace of 1 is 1 upon s, and Laplace of cos t is s upon s square plus 1. That is, now applying Laplace of 1 upon t into ft, which is equals to integral s to infinite fs ds. So this particular will work as fs. So Laplace of 1 minus cos t upon t. First we have to calculate 1 minus cos t upon t. So for this integral s to infinite 1 upon s minus s upon s square plus 1 ds. As solved in the previous question, we solve it, that is integration of log x is 1 upon s is log s minus integration of this particular is 1 upon 2 log s square plus 1. Limit s to infinite, or we can write it as 1 upon 2 log s square upon s square plus 1 under the limit s to infinite. Now to put limit infinite, we have to take common highest degree term from the numerator and the denominator, so that the highest term will remove and the remaining term will be in the form of 1 upon s or 1 upon s square or 1 upon s cube. That is, when we put s equals to infinite, then it will become 0. It means we can change it as 1 upon 2 log 1 upon 1 plus 1 upon s square. Now we can put limit on it. When we put limit infinite, then it will be log 1. When we put s, then it will become as it is, s square upon s square plus 1, and the log 1 is always 0, so it will be minus 1 upon 2 log s square upon s square plus 1. So this is the Laplace transformation of 1 minus cos t upon t, but we have to find the Laplace transformation of 1 minus cos t upon t square. So again we have to apply this particular formula. So from Laplace of 1 minus cos t upon t square, we can write it as Laplace of 1 upon t into 1 minus cos t upon t. That is, first we have to find the Laplace of this particular term, and the Laplace of this particular term is minus 1 upon 2 log s square upon s square plus 1. So for this we can write directly minus 1 upon 2 integral s to infinite log s square upon s square plus 1 ds. Now everybody know the integration of log cannot find directly. We have to apply eilate, and let log is first and this one is s second. So minus 1 upon 2, take outside the integration and apply the formula. First function as it is, integration of second, that is integration of 1, and the integration of 1 is s, minus integral differentiation of this particular log s square upon s square plus 1. So the differentiation of this particular function is 1 upon s square plus 1 into d upon ds of s square upon s square plus 1 into integration of 1, that is s whole ds, limit s to infinite. Either we can write limit with each term, or we can write limit just in the last. Minus 1 upon 2 s into log s square upon s square plus 1 minus integral s cancelled by this s. Now the differentiation of this particular s square plus 1 as it is, differentiation of this 2s minus s square as it is, differentiation of this is 2s upon s square plus 1 whole square into s upon s square plus 1 ds under the limit s to infinite. Now 1 power is cancelled, or minus 1 upon 2 s into log s square upon s square plus 1 minus 2s cube and minus 2s cube cancelled. So 2s upon s into s square plus 1, or we can write it as integral 2 upon s square plus 1 ds under the limit s to infinite. So Laplace of 1 minus cos t upon t square is equals to minus 1 upon 2 s log s square upon s square plus 1 minus 2 is a constant and the integration of is 1 upon s square plus 1, that is integral of dx upon x square plus 1, that is tan inverse x. So 2 tan inverse s under the limit s to infinite. So as solved in previous case, the value of log s square upon s square plus 1 at infinite is 0 and at s it remains as it is. So we can write it as 0 minus s log s square upon s square plus 1 and minus 2 tan inverse infinite plus 2 tan inverse s. So the value of tan inverse infinite is pi by 2 and taking minus 1 by 2 inside this bracket. So this is s by 2 log s square upon s square plus 1 minus plus 1 upon 2 into pi by 2 minus 1 upon 2 into 2 tan inverse s. So s by 2 log s square upon s square plus 1 plus pi by 2 minus tan inverse s, and the value of this pi by 2 minus tan inverse s is cot inverse s plus s by 2 log s square upon s square plus 1. So this is the required solution. So this is example number 3. Find Laplace transformation of e raised to power minus 5t sin 4t upon t. So in this case, we can solve it, either take it entire ft or we can write it as e raised to power minus 5t sin 4t upon t. So first solve it, then apply a method for this particular e raised to power 80 into ft. The solution remains as it is, either we solve by this method or solve by this method. I am solving this particular problem by this method. So Laplace of sin 4t is equals to 4 upon s square plus 16, because Laplace of sin 80 is equals to a upon s square plus a square. Now Laplace of 1 upon t into sin 4t is equals to integral s to infinite 4 upon s square plus 16 ds. So we know integral of dx upon x square plus a square is always equals to 1 upon a tan inverse x upon a. So by this particular phenomena, 1 upon 4 tan inverse s upon 4 under the limit s to infinite. So when we put limit over there, then tan inverse infinite minus tan inverse s upon 4, and the value of tan inverse infinite is pi by 2 minus tan inverse s by 4. So by the inverse trigonometric transformation, it will convert into cot inverse s by 4. Now Laplace of sin 4t upon t arises, that is cot inverse s by 4. Now we have to solve this for this particular exponential term e raised to power minus 5t into ft. From Laplace of e raised to power 80 ft is equals to f s minus a, when Laplace of ft is equals to fs. So this particular cot inverse s by 4 will work as fs. So Laplace of e raised to power minus 5t sin 4t upon t is equals to, what we have to put from there, a is minus 5 and we have to put s minus a, so s minus minus 5, that is s plus 5. So we have to replace this s by 5, s plus 5. So cot inverse s plus 5 upon 4. Or this is the required solution, or we can write by inverse trigonometric transformation it as tan inverse 4 upon s plus 5. So this is the required solution of this kind of problem. Hope you understand the content of this particular lecture. If you like this lecture, then like and subscribe my channel. Thank you.